Hello everyone, welcome to National Standard Examination in Junior Science 2011 Physics Solutions. Let the electrostatic force between two electrons Fe be x times the gravitational force Fg between them. Then x is of the order of mass of the electron 9.11 into 10 power minus 31 kg, charge on the electron 1.6 into 10 power minus 19 coulomb. Electrostatic force between the electrons 1 by 4 pi epsilon naught q1 q2 by r square. By substituting the values we get it as 2.3 into 10 power minus 28 by r square. Gravitational force between the electrons g times m1 m2 by r square. By putting the values we get it to be 5.53 into 10 power minus 71 by r square. By taking the ratio we get the order of magnitude to be 10 power 42. An arrow shot vertically upwards loses its initial speed by 60% in 3 seconds. The maximum height reached by the arrow is, take g equal to 9.8 meter per second square. Let the initial speed of the arrow be u. Given that it loses 60% of the speed in 3 seconds. So the final speed will be 0.4 u. Applying the formula v equal to u plus at. Here since the arrow is shot vertically up, a is minus g. So from there we get initial velocity of the arrow to be 49 meter per second. Now apply maximum height formula u square by 2g. Upon substituting this value we get the maximum height reached by the arrow to be 122.5 meter. A certain force applied to a body A gives it an acceleration of 10 meter per second square. The same force applied to body B gives it an acceleration of 15 meter per second square. If the two bodies are joined together and the same force is applied to the combination, the acceleration will be acceleration of body A equal to F by ma. So it is 10 equal to F by ma, from which we get ma equal to F by 10. On similar lines, we get mb equal to F by 15. Now since the two masses are combined, the total mass of the system will be ma plus mb. So acceleration equal to F by ma plus mb. Writing the values of ma and mb in the expression, we get the acceleration of the combined mass to be 6 meter per second square. A ball is dropped from a height of 7.2 meter. It bounces back to 3.2 meter after striking the floor. The ball remains in contact with the floor for 20 milliseconds. Given that g equal to 10 meter per second square, the average acceleration of the ball during the contact is the velocity of the ball before striking the floor, that is the final velocity of a freely falling body, v equal to root 2gh, that comes out to be 12 meter per second. Velocity of the ball after striking the floor, since it is given that it rises to a height of 3.2 meter, so we can find its velocity again from the formula root 2gh, which comes out to be 8 meter per second. The time of contact is 20 millisecond. So the average acceleration change in velocity by time. So it is 12 minus 8. Since the direction is reversed, we have to write negative velocity for the final velocity. So the final answer comes out to be 20 by 0.02, which is 1000 meter per second square. A loaded bus mass m2 and an unloaded bus mass m1 are both with same kinetic energy. Brakes are applied to both buses so as to exert same retarding force. If S1 and S2 are the distances covered by the two buses respectively before coming to rest, then S1 by S2 is. Both the buses have same initial kinetic energy and both come to rest. So the change in kinetic energy for both the buses is same. Same retarding force is applied to both the buses, so F1 equal to F2. Now applying work energy theorem, W naught equal to delta K, work done is force into displacement equal to delta K. So for the first bus it is Fs1 equal to delta K, for the second bus it is Fs2 equal to delta K. Since delta K is same and force is same, we get S1 equal to S2. So the two buses will travel same distance before coming to rest. In a neon discharge tube 2.8 into 10 power 18 neon plus ions move to the right per second, while 1.2 into 10 power 18 electrons move to the left per second. Therefore, the current in the discharge tube is number of positive ions moving to right 2.8 into 10 power 18, number of electrons moving to left 1.2 into 10 power 18. So the positive ions moving towards right and electrons moving towards left will contribute the current in the same direction, that is towards right. Now the current in the discharge tube I equal to Q by T, that is N1E plus N2E by T. Upon substituting the values, we get the current to be 0.64 amp. In a neon discharge tube, 2.8 into 10 power 18 neon plus ions move to the right per second, while 1.2 into 10 power 18 electrons move to the left per second. Therefore, the current in the discharge tube is number of positive ions moving to right, 2.8 into 10 power 18. Number of electrons moving to left, 1.2 into 10 power 18. So the positive ions moving towards right and electrons moving towards left will contribute the current in the same direction, that is towards right. Now the current in the discharge tube I equal to Q by T, that is N1E plus N2E by T. Upon substituting the values, we get the current to be 0.64 ampere. Three equal resistors are connected as shown in figure. Maximum power that can be dissipated by each resistance is 40 watt. Therefore, the maximum power that can be safely dissipated in the combination is given. Maximum power dissipated in each resistor is 40 watt. So the maximum power dissipation corresponds to maximum current, that is I square R equal to 40 watt. Total power dissipated in the circuit, I by 2 whole square R plus I by 2 whole square R plus I square R, that is 3 by 2 I square R, which comes out to be 60 watt. An object is placed at a distance x1 from the focus of a concave mirror. Its real image is formed at a distance x2 from the focus. Hence, the focal length of the mirror is. See the diagram. Let the focal length of the mirror be f. Object distance u equal to f plus x1. Image distance v equal to f plus x2. Apply the mirror formula. 1 by v plus 1 by u equal to 1 by f. For a concave mirror, all the three quantities are negative. So that is, after sign convention also, the formula remains the same. So we get f square equal to x1 x2, that is f equal to root x1 x2 after simplification. This is also known as Newton's formula for curved mirrors. How much water should be filled in a container 21 cm in height so that it appears half filled when viewed from the top of the container? Take refractive index of water to be 4 by 3. Given depth of the container is 21 cm. Let the water be filled up to 21 minus x centimeter so that the empty space is x centimeter. Since the container has to seem to be half filled, so the depth of empty space should be equal to the depth of water filled height. So we can write a refractive index equal to real depth by apparent depth. So 21 minus x by x equal to 4 by 3, from where we get x equal to 9 centimeter. So the depth of the water in the container is 21 minus x, that comes out to be 12 centimeter. An electron moving to east in horizontal plane is deflected towards the south by a magnetic field. The direction of this magnetic field is. Force acting on a charged particle in a magnetic field, F bar equal to Q times V bar cross B bar. So here the particle is electron, so it is negatively charged. So the force will be in opposite direction to the actual cross product direction. The direction of deflection is nothing but the direction of force on the electron. Since it is the cross product, we can apply any rule regarding cross product. Close the fingers of right hand from first vector to second vector. The thumb indicates the direction of cross product, which comes out to be downward direction. The figure shows a ray of light incident on a convex lens parallel to its principal axis. Obviously, the emergent ray passes through the principal focus. Which of the following statements is correct? The ray bends downwards only once inside the lens. The ray bends downwards at each surface. The ray bends downwards at the first surface and upwards at the second surface. The ray bends upwards at the first surface and downwards at the second surface. A lens can be visualized as a combination of prisms. A ray of light always bends towards the base of the prism, whether it is above the principal axis or below the principal axis. The light ray bends towards the base of the prism. So a convex lens acts as a converging lens as shown in the diagram. Which of the following diagrams do not represent a correct refraction phenomena? As a ray of light travels from one transparent medium to another transparent medium, it deviates from its original straight line path. This phenomena is known as refraction. The light ray bends towards normal in denser medium and away from normal in rarer medium. In the second diagram, Light is bending away from normal in denser medium, that is n equal to 1.5. So this does not represent the correct refraction process. The figure shows graphical representation of sound waves. The quantities on x and y axis respectively are: sound wave is a longitudinal wave traveling in a gas, so compressions and rarefactions are formed when sound is traveling in gas. Compression is the region of high pressure, high density and high temperature, whereas rarefaction is the region of low pressure, low density and low temperature. So the graph represents a distance and a change in density. A certain amount of heat is required to raise the temperature of x grams of substance through T1 degree centigrade. The same amount of heat when taken away from y grams of water, it cools through T2 degree centigrade. Therefore, the specific heat of substance is amount of heat required to raise the temperature of x grams of substance through T1 degree centigrade, Q equal to ms delta T, that is x s T1. Amount of heat required to raise the temperature of y gram of water through T2 degree centigrade, Q equal to ms delta T, that is y into 1 into T2. From the above equations, we can write x s T1 equal to y into 1 into T2. From there, s the specific heat equal to yT2 by xT1. Specific heat of water here in Celsius units is 1 calorie per gram degree centigrade. A boy throws a stone of mass 100 gram vertically upward. It reaches a height of 10 meter and then falls to the ground. The work done by the boy is G equal to 10 meter per second square. Mass of the stone is 100 gram, that is 0.1 kg. Height attained by the stone is 10 meter. So work done by gravitational force is minus mgh, that comes out to be minus 10 joule. So work done by boy will be negative of work done by gravitational force, that is 10 joule. Which of the following does not involve friction? Writing on a paper using pencil, turning a car to the left on horizontal road, a car at rest parked on a sloping ground, motion of a satellite around the earth. Motion of a satellite around the earth involves gravitational force. Centripetal force is necessary for circular motion of any object. In the case of satellite, this centripetal force is provided by gravitational force. Moreover, the satellite revolves around the earth at a height which is greater than the height of the atmosphere, so it does not encounter any air resistance or frictional force. In the circuit shown in figure, if the points A and B are joined by a wire, the current in this wire will be. You see the circuit diagram, the effective resistance of the circuit comes out to be 12 ohm. Current through the circuit is I equal to V by R, which comes out to be 2 ampere. This current is divided equally into both branches as the resistance of both branches is same. Applying Ohm's law, we get Vc minus Va equal to IR, that is 12 into 1, that comes up to 12 volts. And Vc minus Vb equal to IR, that is 12 into 1, that also comes out to be 12 volt. Subtracting these equations, Va minus Vb equal to 0. That means the potential difference between the points A and B is 0. So if you connect a wire between those 2 points, no current flows through it. Two vectors of equal magnitude are inclined to each other at an angle theta. Keeping the direction of one of them fixed, the other is rotated through an angle theta. Now, the resultant of these two vectors has the same magnitude as each of the two vectors. Therefore, the angle theta is. Let the magnitude of each vector be p. By keeping the first vector fixed, rotate the second vector by theta. Now the angle between the two vectors becomes 2 theta. Resultant of these vectors, applying parallelogram law, comes out to be 2p cos theta by 2. That comes out to be 2p cos theta, as the total angle is 2 theta. This result is equal to the magnitude of one of the vectors. So r equal to p. So 2p cos theta equal to p, from which we get theta equal to 60 degrees. Which of the following statements is incorrect? Electric current is a scalar quantity. Electric lines of force are closed curves. Magnetic lines of induction are closed curves. Changing magnetic field induces an electric current in a coil. Electric current is a scalar quantity because it does not obey laws of vector addition. Electric field lines are open lines. They start on positive charge and end on negative charge. So the open lines indicate that the electric field is conservative field. Magnetic lines are closed loops. They flow from north to south pole outside the magnet and from south to north pole inside the magnet. Changing magnetic field induces an electric current in a coil according to Faraday's laws of electromagnetic induction. So the incorrect statement is statement B. Consider points A, B, C and D on a horizontal cardboard equidistant from center O as shown in figure. A copper wire is perpendicular to the cardboard, passes through the center O and carries an electric current flowing upward. Deflection of the magnetic needle will be maximum when it is kept at the point. The current is flowing vertically up in the wire, so the magnetic field lines are concentric circles and they will be in anti-clockwise direction. Horizontal component of Earth's magnetic field always acts from south pole to north pole. So the two fields are in same direction at point A. So the magnetic needle will give maximum deflection at point A.